Hello everyone, my name is Praveen. I welcome you all to yet another lecture on the Docker for Beginners series. Today we're going to talk about images. So images, this particular tutorial will be in much detail because images is the most important concept in Docker. Unless you understand images and how those works in Docker ecosystem, you're not going to understand what exactly the Docker is and what its advantages are, right? So this particular lecture will be a bit technical. If you already know about it or you don't want to understand it in much detail, you probably can stay here for like few minutes and then skip the latter part of it. But those who want to understand it in much in detail, please stay tuned till the very end. Okay. So what exactly is the images? So as I told you in my previous lectures for Dockers as well, is that the way in Java ecosystem you have the artifacts like jar, ERs, wars. The artifact for Docker ecosystem is images. But the very fundamental difference between the images and the other artifacts is that the other artifacts are the single deployable unit, right? Those are the single physical unit which has been there. But in case of Docker, images are not the single physical unit. It's a combination of different layers, I would say, which will constitute the images, right? So if that is not very clear, let's have a look at an example, right? So if you can see my screen, images are basically a build time constructs. What I mean by that is the way you create a jar or a war or something like similar kind of thing in while doing the build. Similarly, you create images while building your project, right? But however, the images are the composition of different units into it. So images can be a combination of your OS files, your application files, then bunch of commands written on top of it. So basically, it's a read-only construct which has been there. So it contains the OS files, app files, and a JSON file which we call a manifest file, which we're gonna see in a later part of this particular lecture. So this is nothing but a particular layers, right? Constitutes a layer. So what exactly is the layers? What you're seeing here is that these are the different layers that I am showing in this black color. So let's say you create an image for, let's say, a Ubuntu operating system, right? So if I want to run any container, I need a, let's say for an example, I want to run a Java based microservice, right? So what all things I need? I need a OS on top of which I'm gonna run my Java program. So I need a OS. I run a JDK install on top of it. Then I need to copy my all the jars which I need into my class path. Then my program files, and then I'm gonna run it. Right. So these are different layers. Right. So Ubuntu installing of Ubuntu is one layer. Installing of JDK is another layer. Then copying of my application jars. That is another layer. Copying of application files in another layer. So these are separate units which has been there. But what Docker does is magically it basically combines all these things together and create a container for it. That is the beauty of Docker, right? So once you create an image, basically these are all read-only files. So this will be copied into a read-only area. So basically you may not be able to modify it. So what exactly is a container? Container basically is a runtime construct, which basically take these files from that particular read-only area and then create a runnable instance out of it. But what if the question which might arise is if you want to write something, because it's a runtime thing, right? You might need to write something. So how does that work? Because what we are saying is that it's image is a read-only construct. What Docker does is for every container. So this is my container, which is I'm highlighting as of now. It creates a particular read-write area for every container. So if you see here, my image is only one, right? Suppose this is my image. Let's say this is a Redis image. Okay, Redis is a caching solution. So let's say this is a Redis image. I have only one image, and from this particular image, I'm running two different containers out of it. Now, it may be possible that these two containers are running in a completely different settings, their own settings, right? They may be writing their own log files, they may have their own settings and all those things. So what Docker does is it basically gives for every container a particular read write area so that every container can copy the files from a read only area, which is the layering or images part of it, into a read write area and then work on top of it. So this is the way Docker works, right? So by copying the files from read only to read write area, and this particular thing or copying thing is called as copy on write. right? By using the copy on write, the Docker works. So if my container gets destroyed, right, this particular read write area will get removed, right? Whatever I have copied onto that particular read write area will get removed, but the read only area will still remain, so that the other container will not get affected at all, right? So this read write area will get destroyed, read only area will remain, and the other container who's using running on that particular image will keep on running it because they are working on their own copy of their data, right? So this is on a high level. This is how the images work. Now we'll go on to a practical aspect of it, and then we'll see how this particular things comes together, right? So I'll go to my Docker terminal and I'll increase the fonts a bit so that everyone can see it. Now what I will do is I'm going to pull a Redis image because that is the example that we see, right? So for pulling the image, I need to run a command called as docker pull, and I say Redis. Once I do that, what's going to happen is it's going to pull a image from a Docker hub, which is nothing but a registry for keeping all the images in a Docker. Now, if you see, this downloading statements is appearing multiple times, right? If it has been a single unit and not the layers, this could have been just a single statement, right? But instead, what is happening is different layers are getting downloaded. So if you see here, I'm actually seeing the 6 different layers which is getting downloaded separately, right? So what's going to happen is there may be a layer for an OS, there may be a layer for some of the binaries which is needed to run a Redis. There may be some of the layer for copying the Redis files and all those things, right? So all those things are getting downloaded separately. If you see here, and once we try to run this particular image, all those things will come together and will be executed as part of a single unit. Now once it's downloaded, it is basically extracting it out, so because it may be in a zip format or something. So now it is extracting it out. It probably try to extract out all the layers which has been downloaded from the Docker registry or the Docker hub. Docker Hub is just a registry for images provided by Docker, but there may be a registry. There is a registry provided by other groups as like Amazon and all other groups as well. If you want, you can install your own on-premise registry as well. So most of the companies, what they do is they basically host their own on-premise registry, so that whenever you are building your application or something, you don't need to contact the Docker Hub, right, or the any third party registry. You can directly fetch the images from your own local on-premise registry, which will be much faster, right? And for the security purpose as well, it is much safer, right? So let it install. Since I'm doing it for the first time, it's going to take a little bit of time, and once it gets installed, we'll see how it looks like. Okay, so our image has been downloaded. So as we can see already, there are 6 different layers. That something we are seeing for this particular Redis image. So pulling a image or downloading an image is basically a two-step process. First, basically you are making an API call using a CLI. That is something we saw in our last lecture, wherein this particular CLI or a command line interface doesn't directly interact with a Docker server. Okay, it basically makes an API call, which is a REST call, and then the REST API basically make a call to a Docker server. So in this particular case, we saw that 6 different layers has been pulled. So how do we know that? Because images are not really a single blob, right? They are different layers stacked on top of each other, which is acting as a single unit. So if you want to see that, what are different layers involved for this my Redis image, how do I see it? So how we can see what all layers which has been involved for this particular image? The simple command for that is docker inspect and your image name. So in our case, it is Redis. So if I do that, it is going to show me the different layers involved. It's basically show us the manifest file for our image. If you see here, there are 6 different layers which I'm seeing as of now in this layers section, right? And we saw that there are 6 different types of thing which is got downloaded when we pull the image. Let's see what all other things which has been there. So there are some other things like what is architecture, Linux, and all those things, drivers, and all those things which has been there. Some environment variables, config, and all those things, right? So you can see here there are a lot many cryptography kind of things which has been there, right? SHA-256. So what are those, right? So let's see what are those. So we got what the layers are. So here we are basically downloading 6 different kind of layers for our Redis image. So let's see how typically the pull command works in case of Docker. So if you can see this particular image, what we are doing is once you do a pull, it basically makes a call, an API call for something called as fat manifest to fetch the fat manifest. So what is a fat manifest, right? So whenever I'm making a call, basically I'm just making a call like docker pull. Now this may be from a Windows machine, maybe from a Linux machine or a different versions of Linux machines. So whatever image that you are pulling, those has to be compatible with the machine on which you are going to execute this particular thing, right? So that is what the fat manifest telling us. If I run this docker system info command, it's going to tell me what is the system info which is I'm having, right? What is the basically kind of a machine on which I'm running this particular docker, right? So let's see. My machine type is Linux because I'm running as a virtual box on top of Windows, which is a Linux based virtual box, and it is an x86 kind of a machine, right? So whenever your images are getting created, you're going to create a different kinds of images. So in our case, let's say if I say a Redis, I'm in Docker Hub. Let's say if you see here, you have a Linux kind of a image, your Windows, your ARM64, x86 64 and IBM and all those kind of images which has been there, right? So fat manifest is basically telling us what is your system info, and correspondingly you get a manifest for that particular system info. After you get that particular system info, you basically get an image manifest for that particular machine, right? And once you get that, then you're going to download the layers on top of it. So this is how the entire image pull lifecycle works, right? For we saw for this particular thing. Now Docker is a bit opinionated for while pulling the images. So if you don't tell its registry, it's going to by default pull it from the Docker Hub. But there is a way by which you can tell as well that what is the registry on which you want to pull it. So uh, basically you can tell what is the registry name. So this registry can be a Docker Hub or it can be something else, right? So after a pull, you need to give options like what is the registry name, and then you can give your image name for it to download. Now let's move ahead. If this is clear till now, we're gonna see what happens or what is those encrypted hashes that we saw, right? So pulling an images is still fine. So how do we make sure that whatever images that we are pulling is exactly the image that is expected to be pulled, right? So what Docker does is it basically creates a hash of the entire content of your image or layers basically, right? Inspect Redis, right? So it basically creates a hash of the entire layers of your image if you see here. And once you pull an image, it basically creates a hash again, and then it basically compares these two hashes together to make sure that they are perfectly matching. If they are not matching, it means your image has been tampered with, right? So by this way, it makes sure that whatever image you are trying to pull, exactly the same image has been pulled, right? Now I'll clear it again. The next thing that we need to see in case of images is if I run it the same command again. Now remember I run the pull command once. Now this particular Redis image is already there into my local machine, right? So if I do Docker images, I should see the Redis image into it. If you see here, this is my image ID and this has been created 11 days ago. I means the creation date, it is basically size and all those things. Now we'll come to tag. What exactly is a tag afterwards? Now image is already there. If I do a pull command again, what exactly happens? Let's see. Right, I'm doing pull again. Last time if you saw, it basically pulled the different layers, and it take quite a long time, right? Now if you see, it didn't pull anything, right? It didn't pull anything. So what exactly it does is it basically get to manifest from the Redis, and then it basically compared that this particular manifest whether it is already present or this particular I would say SHA 256 encoding for my entire content of library, is it already present into my local cache? If it is present into your local cache, there is no need to pull this image again, right? So it basically says as image is up to date for Redis, we don't need to pull it again, right? So this is how basically Docker saves the your bandwidth as well as it speeds up the image pull process, right? It basically constantly check into local cache whether it is already present. If it is already present, there is no need to pull that image again, right? So that is how the caching part of Redis works. Okay, so we saw what the images are and what the layers are. So basically how all those things comes together, right? So let's take an example for the layers. Okay, so whenever the layers are getting downloaded, think of it as different layers getting stacked together, right? So at the very end or the first layer will always be your OS layer because you need to have some kind of OS installed onto your container before you run your application, right? So that would be your OS layer. On top of it, you may have your copying some of the application data. So that would becomes your application layer, and there may be some updates, some other downloadables and all those things. So that would be your third layer, right? So when you download an image from a Docker Hub, let's say this is how they are getting downloaded. Now internally what happens is the Docker file system drivers, they basically combine all these things together and give you a unified view like this, which you can call it as an image. So this is a magic which has been going inside the Docker, which has been done by your Docker file system drivers, and these drivers may depend upon on which version you are running your Docker into. Windows will have a different file system drivers, and Linux will have their own file system drivers. So typically, there is an overlay or AUFS driver which has been executed on top of the Linux. Uh, so basically, the file system drivers will combine all these things together and give you a unified view for the images, right? Uh, so that's it basically. But to recap, what will happen is images are not a single blob of contents. It's basically different contents stitched together, and these different layers are basically unaware of each other, right? So the only entity which is basically aware of these things is a manifest, which is responsible for downloading all these contents together, and the file system is the one who's gonna stitch them all together and give you a unified view, right? So that's from the images perspective. Once you download an image, basically what will happen is they basically gets cached, and the next time you try to download the same image again, it will basically go ahead and check into your local cache if the digest of that particular image or the hash of that particular image already present. If it is present, it will not download it again. It will basically take it from the local cache itself. So that's basically it from the images perspective. Thanks for tuning in, and see you on the next lecture. Thank you so much.